Do you need to be a programmer to build an AI agent? No. In fact, you can build your first useful AI agent without writing a single line of code. But here's the interesting part. As your projects become more powerful, you may eventually need APIs, databases, custom tools, authentication, monitoring, and your own business logic. And that's where coding becomes extremely valuable. So, which path should you choose? No code, low code, or full code development? In this lesson, we're going to break down all three approaches. You'll learn what each one means, what it's good for, where it starts to become limited, and most importantly, which approach you should use for your own AI agent projects. Let's get started. Before we compare no code, low code, and full code, we need to understand one important term: AI Agent Framework. So, what exactly is an AI agent framework? Think of it as a collection of software components, libraries, and patterns that help you build AI systems capable of doing more than simply generating text. An AI model can generate an answer, but an agent may need to decide what to do next, use a tool, retrieve information, remember previous information, execute a workflow, and sometimes coordinate with other agents. A framework can provide building blocks for these capabilities. For example, model interaction, tool calling, memory, state management, workflow orchestration, multi-agent coordination, and evaluation. Instead of building every component completely from scratch, you can use existing infrastructure. But remember this: a framework is not the agent. The framework is the infrastructure you use to build the agent. Think about building a house. The framework is like your construction system and tools. Your AI agent is the actual house you're building. And just like there isn't one construction system that's perfect for every building, there isn't one AI framework that's automatically the best for every project. That's why understanding the architecture is more important than memorizing the name of a particular tool.
Let's start with the easiest approach: no code. No-code platforms allow you to create AI workflows visually instead of writing traditional programming code. Imagine you want to build a customer support assistant. The workflow could look like this. A customer sends a message. The AI analyzes the message. The system searches a knowledge base. The AI creates a response, and the response is sent back to the customer. In a visual builder, you might simply connect these components together. Trigger, AI model, knowledge source, decision, output. You are essentially designing the workflow rather than manually programming every part of it. This makes no-code extremely attractive for beginners. It's also useful for small businesses, prototypes, simple automations, and content workflows. For example, imagine a YouTube research workflow. A topic enters the system, the AI researches the topic, the information is summarized, important points are extracted, and the final research brief is sent to you. You can build a workflow like this without becoming a professional programmer. That's the biggest advantage of no-code: speed. You can test an idea very quickly. But no-code has limitations. You don't always get complete control over the underlying system. Some advanced logic may be difficult to implement. You may depend heavily on the platform. And when workflows become extremely complex, the visual interface itself can become difficult to manage. So remember, no code doesn't mean no complexity. It simply hides much of the technical complexity behind a visual interface. For beginners, that's a feature. For advanced systems, it can sometimes become a limitation.
Now let's move one level deeper. Low code. Low code sits between visual automation and traditional software development. Instead of building everything with code, you use visual components for much of the workflow. But when you need something more specific, you can add code. For example, imagine your customer support workflow.
The visual workflow handles receiving the customer message, calling the AI model, searching the knowledge base, and sending the response. But you have a special business rule. For example, if the customer is requesting a refund above a certain amount, the request must go to a human employee. That custom rule might be easier to implement with a small piece of code. This is where low code becomes powerful. You get the speed of visual development combined with some of the flexibility of programming. Low code is particularly useful for intermediate users, entrepreneurs, automation specialists, and people who are beginning to work with APIs and custom logic. You might use visual workflow builders, pre-built integrations, templates, APIs, small Python functions, or JavaScript and TypeScript. The advantage is flexibility. You don't have to build everything manually, but you're also not completely restricted by the visual interface. Think of low code as a bridge. No code teaches you how workflows work. Low code teaches you how workflows connect to actual software logic. And eventually, that can lead you toward full development. But low code isn't automatically better than no code. If your problem can be solved cleanly with a simple visual workflow, adding code may only make the system harder to maintain. The goal isn't to use more technology. The goal is to solve the problem effectively.
Now we reach the third approach, full code development. This is where you build your AI agent using programming languages and software development tools. Python is widely used in AI development. JavaScript and TypeScript are also important, particularly when building web applications and systems that need to integrate closely with JavaScript-based infrastructure. With full code development, you can create custom agent logic. You can connect your own databases. You can build custom tools. You can implement authentication. You can create complex workflows. You can control how information is stored. And you can build monitoring and evaluation systems around the agent. This becomes particularly important when you're building a production application. Imagine a company wants an AI support system. Thousands of customers may interact with it. The company may need user authentication. Customer records may be stored in a database. Some actions may require human approval. Every important action may need to be logged. The system may need monitoring. And the company may need to evaluate whether the agent is actually producing reliable results. At this level, a simple visual workflow may not provide enough control. Full code development gives you much more control. But there's a trade-off. You need programming skills. Development takes longer. You have more code to maintain. And you're responsible for security, reliability, testing, error handling, and infrastructure. So full code doesn't mean your AI agent is automatically better. It means you have more control over how the system works. And control becomes valuable when the requirements become complex.
Now, let's talk about frameworks. And there's one important warning before we do. Don't try to memorize a list of frameworks and assume one of them will always be the winner. The AI ecosystem changes extremely quickly. Instead, understand the categories. One category is agent and application frameworks. These help developers connect models, tools, memory, state, workflows, and other components. Examples you may encounter include LangChain and LangGraph, OpenAI's agent building tools, Google's Agent Development Kit, Microsoft's Agent Development Ecosystem, and Llama Index. Another category is automation platforms. These are especially useful when your goal is connecting AI to existing business applications. For example, email, spreadsheets, CRMs, databases, forms, messaging platforms, and other business tools. Examples include N8N, Zapier, and Make. But here's the important lesson. Don't choose a framework simply because it's popular. First, define the problem. Then, define the architecture. Then, choose the tools that fit that architecture. Because frameworks will change. Platforms will change. Features will change. But concepts like APIs, tool calling, state, memory,
authentication, workflows, evaluation, and human approval will remain important. That's what you should learn.
So how do these three approaches compare? No-code is generally the fastest and easiest place to start. Low-code gives you more flexibility while still allowing you to work visually. Full code gives you the greatest control, but requires significantly more technical knowledge. Here's a simple way to remember it. No code, maximum simplicity. Low code, balance between speed and flexibility. Full code, maximum control. But don't fall into the trap of thinking more code equals better AI. That's not true. A simple no-code workflow that reliably solves a business problem can be much better than a complicated custom application that nobody understands or maintains. Choose technology based on requirements, not status. If your project is simple, keep it simple. If you need custom logic, consider low-code. If you need deep customization and production control, full code may be the right direction. So what should you actually learn? If you're completely new to AI agents, don't start by trying to build a massive software system. Start with the fundamentals. Understand goals, triggers, workflows, tools, conditions, memory, human approval, and outputs. Then build a simple agent using a no-code platform. Your goal isn't to become an expert in the platform. Your goal is to understand how an agent works. Once you understand workflows, move toward low-code. Start working with APIs. Learn how data moves between systems. Experiment with custom logic. Then, if you want to build more advanced applications, learn programming. Python is an excellent language to learn for AI development. You can then move from simply using AI agents to building them and eventually engineering complete agent systems. Think of the journey like this: AI user, no-code builder, low-code builder, AI developer, AI agent engineer. You don't have to jump directly to the final stage. Build your skills progressively. Let's make this practical. Imagine we want to build one customer support agent. Same goal, 3 different approaches. First, no code. The workflow might look like this: customer message, AI model, knowledge base, response. Simple, fast, easy to test. Now let's make it more advanced. Low code. Customer message, AI model, knowledge base, custom business logic, human approval when necessary, then the response. We have introduced custom logic without building the entire application from scratch. Now imagine the company grows. It has thousands of users. We need authentication, a customer database, custom tools, detailed logging, monitoring, evaluation, error handling, human escalation, and specific business rules. Now, full code development starts becoming much more attractive. The important point is this: we didn't change the goal. We're still building a customer support agent. What changed is the level of control required. No code gives us speed. Low code gives us a balance. Full code gives us control. The correct choice depends on the problem.
Before we finish, let's look at 5 common mistakes. Mistake number 1: choosing a framework before defining the problem. Don't start with, which framework should I use? Start with, what am I trying to accomplish? Mistake number 2: using multiple frameworks unnecessarily. More frameworks don't automatically create a better agent. Every additional technology can introduce complexity. Mistake number 3: assuming no code means no complexity. A visual workflow can still contain complicated logic. Mistake number 4: assuming coding automatically makes an agent better. Code gives you control,
It doesn't guarantee reliability. And mistake number 5, building an autonomous agent before proving the workflow. This is one of the biggest mistakes beginners make. They try to create an agent that can do everything. Instead, start with one small workflow. Test it, measure it, improve it, then add complexity.
If you remember only one thing from this lesson, remember this. Start simple. Prove the workflow. Then add complexity. Don't build a 10-agent system when one agent can solve the problem. Don't write 1,000 lines of code when a simple workflow is enough. And don't automate a process that you haven't made reliable manually. First, make the process work. Then, automate it. Then, improve it. That's how you build useful AI systems. Let's quickly recap. No-code is the fastest way to start. Low-code gives you more flexibility and custom logic. Full code provides the greatest level of control. But the most important lesson is bigger than any particular framework. Learn the architecture first. Learn how agents use models, tools, memory, state, workflows, and human approval. Then choose the technology. Now it's your turn. For today's practical assignment, choose one project: a YouTube research agent, a customer support agent, an email assistant, a study agent, or a business report agent. Then answer 3 questions. Number 1, can no-code handle this project? Number 2, would low-code provide meaningful advantages? Number 3, would full code provide meaningful advantages? And most importantly, explain why you made your choice. In the next lesson, we're going to take these concepts and actually build something. We're moving back into hands-on territory. We'll create your first real no-code AI agent and connect an AI model to tools and a practical workflow. I'll see you in Lesson 12.